Hello, good morning everybody. My name is Vishvadeep and I welcome you all on Unacademy Computer Science Channel for unlimited learning. Today's session will actually mean my words unlimited learning just because we are going to solve 60. Yes, my friends, 60 only multiple select type of questions on only computer organization and architecture. So I have prepared these questions for you guys so that you can learn computer organization and architecture's small very fine detailed description, and you can learn a lot from those kind of things. So let's get started with that particular session. Remember, we are going to solve so many questions, and not I am going to solve, you guys will definitely attempt these questions. If you are listening this particular lecture in offline mode, then I want you to stop your video after every question and try to solve these questions by yourself before you check out the solution. One thing for sure I can tell you, that you will learn the methods, you will learn the approaches, and you will learn the actual thinking behind solving the MSQ questions in your GATE exam. So whenever you will be seeing those questions, MSQ type of questions in the GATE exam, you need to feel it, that how exactly you will approach the question. You need to learn now that how exactly you are going to solve those questions in the exam, and that is what I have brought for you in this particular session. So this will not be only you will learn the technical things and all, you will learn how exactly you are going to approach such kind of question, and which is more important for you guys to learn, just because it's a new kind of questions will be asked in the GATE from this year onwards. Chaliye, so let's get started without any delay. Before we start, let me introduce myself for those members who don't know about me. My name is Vishvadeep. I am right now Unacademy's branch team's computer science head. I have written GATE multiple times. 19 rank is my final year rank in engineering. Before that, in third year, I could score 682. And then I was able to score few of more ranks in the GATE computer science, like 119, 440 and so on. Went for my masters to IISc Bangalore, another masters from BITS Pilani in data science. Total 13 years of experience, 9 plus years only for GATE. And this particular teaching experience is not tuitioning the students of school. I have always taught and only taught engineering students only for their preparation, for their programming, for their regular classes and all. These are the courses right now I am taking on Unacademy's platform. Computer organization, as you are seeing, so many lectures. Data structures, which is already going on Monday to Friday 10 a.m. and coding interview problems, which I have already taken a lot of session about on the same channel. You can check it out. If you want to learn more about my classes, then you can follow my profile over Unacademy's platform also. Go to the unacademy.com or download the Unacademy app, and then on that you just follow my profile. What you will get over there is special classes. If you will check out the special classes, these are the classes which we take for free. Those so many special classes I have already taken. Go and check it out. You will be able to check it out. Plus so many special classes I am taking for free live also. You can learn those also, like a revision session I have started for data structure. So if you have already done with data structure, let's revise entire data structure quickly with this revision session that comes at 3 p.m. It's tomorrow. I am having another session from tomorrow 3 p.m. You can join live and learn on Unacademy's special classes. If you want my all the special classes in organized way, go to this particular URL. When you will go to this URL, you will be having all my special classes arranged, organized in a appropriate way. So you can access all the classes and their links from this particular URL. Another opportunity for you guys is this one. If you go and check out this particular test series, it's a test series for free we have brought for you, and that particular test series contains around 20 tests of different subjects and combination tests we are having, and these tests are for free. Enroll and just assess your preparation, that how exactly you have prepared and what exactly your status is in the preparation. Check it out if you are able to solve more questions or not, if you are able to solve tough questions or not, complex questions or not, and so on. If you are not able to solve complex questions still, even though knowing lot of things, then the problem is mapping. Mapping is whatever you know from there to how to solve a question, that particular mapping is missing, and that particular mapping, that particular bridge, we provide you on Unacademy Plus. If you are still lacking in your preparation, that sir, we are able to understand every concept, but we are not able to approach how to solve a question, we are not able to understand how to solve a question, we are not able to understand sometimes what is the demand of the question, then all these things can be solved if you will be coming on Unacademy Plus. On Unacademy Plus, we provide the classes in such a way that you will understand each and every topic in 4 different perspectives. After that, you will solve the questions of all 4 perspectives, and after that you will be writing a test, a quiz, weekly to a quiz, and because of that your overall grooming will be a lot really better. And this particular thing we always urge you to tell you ki you, if join Unacademy Plus, it will make a huge impact on your final results. And because of that, we always tell you ki join Unacademy Plus. If you are really thinking ki yes, my aim is to reach to IITs or IISc or something, then my dear friends, learning from free sources can give you every single knowledge, of course, but the past history is around 95% students were not able to achieve whatever they intended to from learning from free sources and in the free environment. The probability is very less, possibility is there, but probability is very less. If you want to increase that probability, you need to come to Unacademy Plus. If you want to come on Unacademy Plus, very simple thing you can go with is use this particular code for your Unacademy Plus subscription, VDeep10, and using that particular code you can get a discount, plus you will be eligible of my mentorship, plus you will be eligible for support of my entire team. Lots of things will be there, but most important thing is your career, which will be definitely have a great impact on your final result. Another thing is, if you are the person who needs a planning and strategy done by somebody else for your specific personalized way, then you need an Iconic subscription. This Iconic subscription has all the facility of Unacademy Plus, and other than that, a personal coach facility which prepares strategy for you, which prepares a study planner, customized plan for you, which gives you study planner, study booster sessions, will give you personalized test analysis, so that if you get less marks or if you get any mistakes in the test, then definitely those tests will be analyzed, and next time onwards you will try to improve those test marks. Other than that, we will provide in Iconic subscription you extra study materials, notes, practice sets, and so on. And this Iconic subscription also you can get with discount if you use the code VDeep10. remember, code आपको यूज करना है VDeep10, इससे मिलेगा आपको 10% का डिस्काउंट, साथ ही साथ बहुत कुछ, so much. So don't waste your time and just come on Unacademy Plus, whatever the remaining time is for your preparation, whether you are preparing for gate 22 or 21. If you really want that, you want to achieve something better in your life, then invest your time, invest your money, invest your efforts in that particular thing. You will definitely be focused about that, and you will definitely get the result out of it. So if you are fine with this, I want to start the session now. But before that, as always, I need your approval. If you will approve, if you will say you are ready, I want the highest enthusiasm today, just because we are going to solve 60 questions. Yes, my friends, 60 questions of MSQ type, and it's not only that I'm going to give you the answers ki this question's answer is ABC, or this question's answer is ABD, this question's answer is B and D, and so on. I want you to learn the approaches how you are going to attempt the questions in the exam. So one person who has written the GATE exam multiple times, having the experience lot of training and teaching the students, writing the GATE exam, lot experience if I am having, then definitely my teachings will help you in that way ki how exactly you can attempt the question in the exam, so that in the less time you can get the correct answer in that correct approach. So if you are ready, yes, you need to show your enthusiasm, your excitement. And one more thing, if you haven't liked the video, please like kar do video ko. And one more thing is, if you haven't shared the video, please share the video with all of your friends so that all those also can join here. I want maximum participation of students so that we all will have a great learning environment today in this special session. So what do you say? What do you say? Should we start kare ya nahi? If you will say start, I will show you the very first question. The very first question may be very easy, but the thing is, slowly of course yaar, fifth gear mein jaane ke pehle first gear lagayenge, then second, third, fourth, fifth, and then we will run on the fastest possible speed. So let's get started, and here is first question for you. What is the question? The question is, one address instructions are supported in. One address type of instructions are supported in which type of architecture? So you should first understand what is one address instruction. As soon as you read one address instruction, immediately your mind should click ki one address instruction means apart from opcode, one address is required. Now next, AC based architecture, accumulator based architecture, immediately you need to understand if one address instruction is this ki apart from opcode, you need to mention one address only, that is one address instruction. In accumulator based architecture, can we have support of one address instruction? Yes, we can have. Why? Just because accumulator based architecture uses one address instructions only. If you remember accumulator based architecture, I told you in the classroom ki accumulator based architecture is that architecture in which we will provide explicitly one address, another operand will be taken from accumulator already implicitly. So yes, register based architecture, yes, in the register based architecture we can have maximum 2 or 3 operands. So 2 address instruction register based architecture supports, yes. So if supports 2 address, then of course it can support 1 address also. Now stack based architecture, no. In stack based architecture we have only 0 address instruction supported. Only 0 address instructions supported. That's wrong. That is wrong. And one last, register memory based architecture, yes, you can have 2 address, 3 address type instruction, 1 address type instruction, 0 address type instruction supported in this register memory based architecture. So A and B and D are correct for this particular question. Now, how you learned this? What you learned from here is every statement you should know about, every type of architecture you should know about, then only you can say this is correct and this is not. And that is what the difficulty you will be facing in the GATE exam. When students say, sir, exam will be tough this year, only one thing will be tough this year is these type of MSQ questions, just because these MSQ questions will require lot of understanding of the topics from your end, just because every single statement, every single option should be easy for you. If you will be able to understand every option, then only you will be able to solve the question, otherwise not. Chaliye बढ़ते हैं आगे. Question number 2, which of the following cache mappings may experience conflict miss? Conflict miss, first of all you need to understand what is conflict miss. Conflict miss means if the cache memory is not full, but just because one set is full, one particular set is full, or a block is full, here one index is full, and because of that if a block is replaced, and if that block is again again referred. Okay, let me first explain you, we will come to the solution, later on. I'll tell you first. Suppose block 1 is present here, and along with that block 5 is present here on some block in or on some set in cache. Some new block comes, block number 3, and block number 3 replaces block number 1, just because in this set you can keep only 2 blocks. Now let's say if this particular block number 1 again got referred, cache memory is not full, but just because my set was full, conflict miss occurred. Yes, so conflict miss can occur in direct mapping. Yes, conflict miss can occur in two-way set associative. Yes or no? Yes. Four-way, yes, but fully no. In fully associative mapping, if you say set is full, means entire cache memory is full. Entire cache memory is full. A, B, C are correct. Look at this. In fully associative mapping, we keep all the blocks in the same set. सारे के सारे blocks उसी set में हम रख देते हैं. So if we keep all the blocks in the same set, what happens if we say set is full, means cache memory is full, which means in the fully associative mapping you may have cold miss or you may have capacity miss, but you will never have the conflict miss. No conflict miss can occur in the fully associative mapping. समझे कि नहीं समझे? आप समझ पाए कि नहीं समझ पाए? अगर आप लोग समझ रहे हैं तो फिर हम आगे बढ़ेंगे. इफ यू आर अंडरस्टैंडिंग देन ओनली वी विल गो फर्दर. चलिए बढ़ते हैं आगे. अगला क्वेश्चन नंबर 3. नाउ आई वुड लाइक टू हैव द आंसर फर्स्ट फ्रॉम योर एंड एंड आफ्टर दैट आई विल स्टार्ट एक्सप्लेनिंग यू. क्वेश्चन नंबर 3. Which of the following solution for pipeline hazard is or are not provided by compiler? Not provided by compiler. Branch prediction, yes, not provided by compiler, just because it's a solution, hardware solution. And next, delayed load, yes, it is provided by compiler. Delayed load is provided by compiler for the data dependency solution. Next, prefetch target instruction also not provided by compiler. Why? Just because it is provided in the hardware. So these two solutions, branch prediction is hardware solution for branching, prefetch target instruction also hardware solution for branching, and this delayed load provided by compiler for data dependency, delayed branch provided by compiler for branch problems or control dependencies. So what are not provided by compiler? A and C. Now look at this. You know what is my approach for MSQ? For MSQ, my approach is every single statement I am reading, I am mapping to my solution, and after that I am judging that this particular option is correct or not. So it's like 4 true false statements you need to solve, or 4 true false questions you need to solve in the MSQ type question. 4 questions in the single question, just because for every statement you need to be very sure, for every option you need to be very sure, then only you will be getting the accurate correct marks for that particular question. That is why MSQs will make a lot of impact in your final results. चलिए आगे बढ़ते हैं. क्वेश्चन नंबर 4 ये रहा आपके सामने. Which of the following control unit organization can be faster than nano programmed control unit? अब आपको nano programmed control unit पता होना चाहिए. Are you aware of nano programmed control unit? And which one is faster than nano programmed control unit? Okay, so we know कि hardwired is fastest, so I can go with this. Now I need to compare nano programmed control unit with B and C also. Horizontal microprogrammed control unit is faster than nano, and vertical microprogrammed control unit is faster than nano or not. Then for that we need to understand the working environment of these nano-programmed horizontal and vertical microprogrammed control unit. I'll tell you one thing. I will explain you what exactly you do in the horizontal microprogrammed control unit. In the horizontal microprogrammed control unit, you have one memory access, one control memory access for getting the control word, one memory access, right? And there is no any decoder. You remember, there is no any decoder, of course, right? So one memory access. Now let's see vertical. In the vertical microprogrammed control unit, we have one control memory access plus decoder also. Yes or no? Yes or no? Yes or no? Yes or no? Yes. In the nano programmed control unit, we have two memory accesses. We have two memory accesses. Why? If you remember the concept of nano programmed control unit, I only explained in my all the lectures, whether it is on Unacademy Plus or on YouTube. I have explained this कि we keep two memories, one for only sequencing, one for storing the unique control words. If you remember, you need to answer it. If you don't remember, go back and check it out. You need to remember all these things. Now see which can be faster. If two memory accesses, of course two memory accesses are slower यार. Slow होगा ही होगा. Then one memory and decoder, then one memory access. Of course two memory accesses will be slower. Decoder is hardware dear. Hardware is always faster than memory access, of course. So horizontal also will be faster and vertical also will be faster. I will give answer as A, B, C. All will be faster than nano programmed control unit. Now see what can be one of the problem with you guys is you guys might face the problem of not remembering the concept. Might possible that you know the concept but you are not able to remember every single small things, and that is what can make a big difference. Okay, so you need to revise, you need to properly remember all the concepts. Let's go for the next question. Very good morning everybody who have joined little late. Please like the video अगर like नहीं किया है तो, और साथ ही साथ सेशन को शेयर करते जाओ अपने फ्रेंड्स के साथ में. Now which of the following signals can be generated during execution of instruction? First one is HLDA. HLDA एक वो सिग्नल है जो CPU to DMA controller जाता है for granting the DMA. DMA grant, it is DMA के लिए bus grant signal होता है. Okay, remember HLDA signal is that signal which CPU generates for DMA for the granting the bus for the DMA control or for the DMA transfer. Now give me the answer first. ऐसा कौन सा सिग्नल है जो एक इंस्ट्रक्शन के एग्जीक्यूशन के टाइम पे नहीं जनरेट हो सकता? इंस्ट्रक्शन एग्जीक्यूशन, if going on, then DMA acknowledgement can be done. Yes, DMA can be serviced during or in between the execution of instruction, possible. INTA, interrupt acknowledgement, no, just because we always have seen this कि from CPU to the device the signal interrupt acknowledgement will be sent only when the current instruction execution is completed. When the current instruction is completed, after that only CPU will go for interrupt service. So acknowledgement of the interrupt cannot be given during the execution of an instruction. Memory read signal, of course CPU can read a memory during instruction execution. Of course अगर operand की जरूरत पड़ती है, in operand fetch CPU may go to the memory and can get the operand from there. IO read, yes, possible IO read also. So answer should be A, C and D. Is everything clear till now? Yes or no? A, C, D are clear. Got it or not? Great. I can see lots of messages and lots lots of correct answers also. That's amazing, pretty amazing. Another question. Question number 6. Which of the following is or are solution for control dependency? Control dependency means what? Control dependency means branch problem in the pipeline. ब्रांच प्रॉब्लम इन द पाइपलाइन. अरे ये ब्रांच प्रॉब्लम पाइपलाइन की है, आपकी नहीं सर. सीएस ले लिया, अब मजा नहीं आ रहा प्रोग्रामिंग में, अब क्या करें? अब कुछ नहीं, हवन कर लो. ओके, नाउ see if branch dependency or control dependency we have, loop buffer is a solution. Yes. Delayed branch is a solution. Yes. Delayed load, no. Delayed load is the solution for data dependency. अभी थोड़ी देर पहले ही तो बताया था मैंने. थोड़ी देर पहले ही तो बताया था मैंने. Data dependency, yes, and prefetch target instruction, yes. So A, B, D are the solutions for the control dependency. There can be more solutions apart from these. One can be prefetch, okay, prefetch target instruction is there. One can be delayed branch provided by compiler, and one can be target instruction buffer. So there are multiple more solutions of the branch dependency. Here is question number 7 in front of you. Are you ready? Are you excited of solving this question? चलिए अगले देखते हैं. Question number 7. Which of the following cache mapping for block replacement any policy is needed? In which of the following cache mappings for block replacement any policy is needed? So first of all, we need to understand in the direct mapping on a set, on an index, we can keep only one block. If we can keep only one block, then if any replacement happens, for replacement, we don't have any choice for replacement. So there is no any policy needed in the direct mapping. Two-way, yes needed. Four-way, yes needed. Fully associative, yes needed. In the direct mapping, no any replacement policy needed. If you are following my YouTube lectures, I guess yesterday only I have talked about this, few days back only, within few days only I have discussed this block replacement topic in the YouTube session. Yeah, okay, so direct mapping, no any policy needed, but two-way or any set associative or fully associative mapping will need the replacement policy. अब बोलोगे सर आपको इतना कैसे याद रहता है, हमको तो याद ही नहीं रहता, we can't remember these things. Only simple thing is there, multiple time revision. I have revised these topics multiple times for teaching. Why? Just because since last almost 10 years I am teaching these topics, buddy. So if 10 साल से मैंने more than 100 times same topic पढ़ाया है, more than 100 times, if you will read one thing, definitely you will remember. Like you remember 2 plus 3 is 5. You don't have to calculate it like that way, right? No, why? Just because you have done it 100 more than 100 times, 2 plus 3, 2 plus 3, 2 plus 3. It's very simple. Okay, another thing is next question. Which of the following details are required to declare a hit or a miss in the cache? To declare a hit or miss in the cache, what are the details required? So tag is required. Yes, tag is required for the tag matching. If the tag matches, then only say hit or miss. Cache block number, yes, for the mapping it is required. Set number, yes, for the mapping it is required in the set associative mapping. Byte offset, no. Byte offset just tells me कि if there is a hit, then which byte CPU requires. If there is a hit, which byte of the block CPU requires. So if you remember this point, I would like to repeat it once again. Mapping happens on the blocks. Mapping is implemented on the blocks. तो अगर mapping block पे होती है, तो block पे क्या होता है? On the blocks, first we check that this particular block is having hit or miss in the cache. If there is a hit for that block, CPU doesn't require entire block. CPU requires only a byte from that block. So which byte? This byte offset tells us that which byte CPU needs. So once the hit is declared, this byte offset is used to access a specific byte. But to declare hit or miss, byte offset is not needed at all. Byte offset की जरूरत नहीं होती है. Cache block number and tag in the in the direct mapping, and cache set number and tag in the set associative mapping can be used, and in the fully associative mapping only tag is used to declare hit or miss in the cache. Is that clear? Is that clear? Is that clear? आगे बढ़े क्या? आगे बढ़े, आगे बढ़े, आगे बढ़े, आगे बढ़े. क्या आप लोगों ने नाश्ता कर लिया? ब्रेकफास्ट हो गया? चाय नाश्ता हो गया? या अभी भी बेड पे पड़े हुए हैं आप लोग? उठो भाई, आंखें खोलो, दिमाग खोलो और अच्छे से नेक्स्ट क्वेश्चन का आंसर सही देना है आपको. नेक्स्ट क्वेश्चन, करेक्ट आंसर यू नीड टू गिव. Which of the following time is or are not included in calculating the transfer time for the magnetic disk? So you are going to calculate only transfer time for the magnetic disk. So calculation of magnetic disk's transfer time, which time are not included? Not included. Seek time, not included. Seek time is actually included in the disk access time but not in the transfer time. In the transfer time only sector transfer time is calculated. Only sector time or sector transfer time is needed. Only sector transfer time is needed for disk transfer time or disk transfer rate calculation. So seek time not needed. Yes. Rotational latency, no, it is not needed. Latency is not needed. Sector transfer time needed. Controller's delay not needed. So only sector time is needed. Okay, people say it. C and D. Might possible you may require controller delay, but most of the time only this particular sector transfer time only will be included in the calculation of transfer time. So we will be going with C option as not included. A, B, D not included, not included, not included. जरूरत नहीं है. A, B, D की जरूरत नहीं है ट्रांसफर टाइम कैलकुलेट करने के लिए. Only sector transfer time. Look at this, not included लिखा है रे बाबू. थोड़ा सा ध्यान रखें. See, you will be tricked in the questions most of the time. Not true, not false, yes, true, correct, incorrect. All these you need to understand. Right? Not incorrect means it is correct. Such kind of statements you need to understand in the exam. हम incorrect word पढ़ते हैं, not आगे का आगे पीछे का. अरे सर जो भी लिखा है हमने देखा ही नहीं, हमने तो incorrect देखा, हम बढ़ गए आगे. तो वो लोग भी जीरो देखेंगे और आगे बढ़ जाएंगे, या नेगेटिव मार्क्स देख के आगे बढ़ जाएंगे, है ना. तो ध्यान रखें, अच्छे से सॉल्व करें. और ये देखिए अगला क्वेश्चन, क्वेश्चन नंबर 10. विच ऑफ द फॉलोइंग इज और आर ट्रू? रीड एंड ट्राई टू गिव द आंसर. इफेक्टिव एड्रेस फॉर एनी ब्रांच इंस्ट्रक्शन इज ऑलवेज कैलकुलेटेड even though if the branch is not taken. So if you remember the regular branch instruction execution, first of all, for any instruction execution, instruction fetch happens. What happens in the instruction fetch? Instruction will be copied into CPU. Fine. After that, decode happens. Instruction decode. In the decode, CPU will detect that this instruction is branch type instruction or what type of instruction. Then after that, third one is address calculation, effective address calculation. In the effective address calculation for the branch instruction, CPU will calculate the target. Definitely will calculate the target. After that, CPU will go for operand fetch and then execution. In the execution, CPU understands कि condition is true or false. The condition will be evaluated in execution phase, but before that, effective address will be calculated for the branch instruction. If condition is true, PC updated by effective address. If condition is false, don't use that effective address, but effective address is calculated. So it's true statement. It is true statement. Now, main memory is directly accessible from CPU. Yes, main memory is directly accessible from CPU. That's a true statement. At a time, more than one read-write head can transfer the data from the disk. No, only one read-write head can be active at a time in the disk. Only one read-write head can be active at a time in the disk. Control unit only generates enabled signal at a time? No. Control unit generates all the signals, whether it is enabled or disabled, at every single time. So if control unit generating signal, it is generating all possible signals, whether it is enabled or disabled. It will generate all the signals. All these points I talk about in my regular class at every place. In the Unacademy Plus also I told, on the YouTube also I told all these. So answer is A and B are true. A and B are true. नहीं नहीं, D भी false है. D false है, true नहीं होगा. Okay, okay, okay. अभी तो 10 ही क्वेश्चन हुए हैं यार. अभी 50 क्वेश्चन और बचे हुए हैं. 50 questions are still coming. Next particular question is this. Which of the following addressing mode supports runtime relocation without any change in the code? You want to relocate something, but you don't want to change the code. You don't want to change the any kind of thing in your program. What are the addressing modes? PC relative mode? Yes. Base register mode? Yes. These are the modes which will be used for the relocation. Okay, this is very simple question. This is one of the most popular question from the addressing modes. Another one. Which of the following addressing modes is or are used for accessing the array elements from the memory? कौन सा ऐसा एड्रेसिंग मोड है जो आपको एरे के एलिमेंट को एक्सेस करने में हेल्प करेगा? जल्दी से आंसर दो. आई वांट आंसर फ्रॉम योर एंड. Need the answer. I want answer. I need answer. Come on, come on, come on. Scaled mode is used for array access? Yes. Indexed mode? Yes. Index plus base register mode? Yes. Auto decrement mode? Yes. It can be used for array access in the reverse order. All these modes will be used or can be used to access the array element. Yes, possible. All, ABCD, ABCD, ABCD. It's a movie name. Okay, next. Another question. Question number 13 in front of you. Question number next. Are you ready? Ready. Okay, here it is. Question number 13. Which of the following can be the value of PC immediately after fetch of an instruction which is stored on location 400? If there is an instruction stored at 400 and CPU wants to access that particular instruction, fetch that instruction, first of all PC should be having value 400 initially. After the fetch, PC value increments. Yes. So immediately after the fetch of this instruction, what can be the value of PC? Now, I told you clearly in my classes कि when the instruction fetch is done, PC will be incremented and PC will be incremented by the size of instruction. Is there any mention of the size of instruction? No. It can be of one size? Yes. It can be stored on 2 addresses? Yes. It can be stored on 3 addresses? Yes. It can be stored on 4 addresses? Yes. So possible PC value can be 401 or can be 402 or can be 403 or can be 404 based on the instruction size. Of course, it cannot be A, it cannot be B, definitely it can be C, it can be D. So can be possible values of PC can be 401 if instruction is stored on only one address, can be 402 if instruction is stored on 2 addresses. Answer will be C, D. आप लोग बात करते जाइए. बहुत बढ़िया यार, बहुत सही, बहुत शानदार, अमेजिंग. I am enjoying along with you guys. Let's get to the next question. So many members have given the correct answer. स्वागतो, नाइस. कार्तिक, तलहा, तलहा ने डी भी आंसर दिया है. ओके, सी भी आंसर दिया है और बी भी दिया है. Okay, Abhishek Mishra, nice. Shweta, nice. Parvej, nice. Kanchan, superb, amazing, amazing people. Everybody. Sarvesh Kumar and Mayuri and so many members have given the correct answer. Now listen, next question is coming in front of you. Just check out, think of it, and solve the question correctly. Concentrate. Put your every single concept here and try to solve the question. Question number 14. Here it is. Which of the following is or are not true for asynchronous serial data transfer? Not true means false. Okay. Start stop bits are sent along with each character. It's a true statement. It is a true statement. For each character, we are going to send start stop bit. Start stop bits are sent along with each word. Block of words? No. False. Effective data transfer time is increased. Effective data transfer time is increased. Yes, increased. Yes, increased. And then effective data transfer time is decreased. No. See, look at this. Effective data rate decreases, transfer time increases. So transfer time increases. Yes. Time decreases. No, false. So which option is not true? Which option is not true? B and D are not true. Now listen, कभी कभी ऐसा भी हो जाता है. Sometimes it might possible. It might happen कि you will get the correct answer. A, B, C, D. Yes, I got to know. A is correct. C is true. B and D are false. And you will go with the reverse way. They have asked true. I have gone for true. But they have actually asked not true, re babu. Right. False asked. Yes, false asked. False asked. तो याद रखें B and D will be the correct answer. Okay. Remember these kind of small points. When you solve the question, I'll tell you what happened. When you solve the question, it's my own experience of writing the GATE exam multiple times. This is why I write the GATE exam. You know, when you solve the questions, your mind will be engaged into the technical things a lot. So effective data transfer increase hota hai ya decrease hota hai. So your mind is engaged into that. You will not be able to put a little extra concentration on any other thing. And in that case, what happens, once these 4 statements are done, true, false, you detected, then after that your concentration is still in the technical things. You will not be able to come back on the question, and you might miss this point ki it was a true or false, and you might go with the false if true is asked. You might go with the false if true. You might go with the true if false is asked. And such kind of things happened with me. So what I do, I recheck it. What is the question? They have asked true, false. Okay, this is true, this is false, this is true, this is false. Yes, I got it correct. Okay, let's go for the next one. And hardly it takes 10 seconds extra. If you recheck what is asked and what I have clicked. So whatever the answer you click on the computer screen, recheck it immediately ki your answer is this and you did it correctly or not. When you type the numbers, suppose a large number is there, 4-digit, 5-digit number in NAT type of question, in that type question, might possible you may have mistyped answer. Mistyped answer hota hai, possible. Human errors are possible, manual errors are possible. So you just recheck whatever is the answer. Okay, answer is this, my answer is this. No, it is not correct, I have typed it incorrectly. There you will not be able to put a star and resend the message. अरे IIT वाले रुक जाओ यार, मैंने वो टाइपिंग टाइपो एरर हो गई थी, ये वाला नहीं, ये वाला आंसर करेक्ट है. ऐसा नहीं हो पाएगा. So please recheck once again before sending the final answers. Okay, remember these points, small points, but these may have a large difference in your exam result. Another question: consider the system in which in fetch cycle complete instruction is fetched. Okay, so in instruction fetch you fetch entire instruction. Which of the following addressing modes do not or does not require memory access for operands? For operands means data. After instruction fetch, For operand fetch, there is no any memory access required after the fetch cycle. Not require the memory access. मतलब memory तक आपको नहीं जाना होगा operand लेने के लिए. So which addressing mode does not require memory access? Register mode, yes, does not require memory access. Operand is available in the register itself. Register indirect mode, no. In the register indirect mode, the instruction specifies the register, but in the register you get the effective address. Using that address, you need to go to the memory. Indirect mode, not at all possible. Why? Just because in the indirect mode, you will have to anyway go to the memory. Indexed mode, no. In the indexed mode, you calculate effective address by addition of base plus index. It is not the operand, it is the effective address. So after effective address calculation using this effective address, you need to go to memory to get the operand. तो आपको मेमोरी तक तो जाना ही पड़ेगा. सो किस में मेमोरी एक्सेस नहीं होगी? सिर्फ ए में. ओनली ए इज करेक्ट आंसर. ओनली ए इज करेक्ट आंसर. ओनली ए, ओनली ए, ओनली ए. Now, let's go for next question. Let us go for the next question. अगला क्वेश्चन ये रहा आपके स्क्रीन पे. Are you fine with the next question or not? If you are fine, let's go for the next question. Consider a system which supports 2 address and 1 address instructions both. Okay. System has 20-bit instructions, 7-bit addresses. Then which of the following is or are the number of 1 address instructions possible in the system? It's a numerical question and it will take a little time to be solved. Fine, I am solving for you. You solve before me. पहले पहले आप सॉल्व करते रहो, पीछे पीछे मैं भी सॉल्व करूंगा. इफ यू स्टक समवेयर देन यू कैन टेक माय हेल्प, बट यू सॉल्व बिफोर मी एंड यू गेट द आंसर बिफोर मी. यू गेट द आंसर बिफोर मी. पहले मुझसे पहले आपको आंसर लेके आना पड़ेगा. सो first of all, 2 address and 1 address instruction supported. Let's draw the format of 2 address and 1 address instruction. Opcode, address number 1, address number 2. And here is the format, opcode and address number 1. Now, 20-bit instruction. Okay, fine. So total 20-bit instruction. Here also 20-bit instruction. Fine. Next, how many bit addresses? 7-bit. 7-bit addresses. So if 20-bit instruction 7 here gone, how many bits for opcode? 20 minus 14, 6 bits here. 20 bits. Okay, here 7 bits address, then how many bits opcode? 13 bits. Now if you remember my lectures, I told you need to start with that instruction which has minimum opcode bits. Let's go with this minimum opcode bits. Minimum opcode bits 6. With these 6 bits, maximum how many opcode combinations we can generate is 2 power 6, 64. 64, right? Among those, do we have any kind of number of 2 address instructions are given? No. Number of 2 address instructions are given? No. If number of 2 address instructions are not given, then I would like to understand the scenario here. Key, based on 2 address instructions only we can have 1 address instructions? Yes. So based on, if using 2 address instructions only you can have 1 address instruction, then I would like to go with one thing. Let's try to calculate maximum possible 1 address instructions. Let's try to calculate maximum possible 1 address instructions. To get the maximum possible 1 address instructions, I will take minimum possible used opcode for 2 address instruction, which is 1. I will take minimum possible used 1 address instruction, used 2 address instruction, so that maximum possible 1 address instruction I can understand. Okay, now if used opcode is 1, how many unused opcode I'll be having for 2 address instruction, which is 63. These 63 combinations I'll be using to form the opcode for one address instructions. So in the opcode of one address instruction, 13 bits are there. These 13 bits I'll have to divide into two parts. You remember, first part will have 6 bits. Why? Just because previous level have 6 bits in opcode and remaining 7 bits separate. Remaining 7 bits separate. Now listen. These 6 bits, using these 6 bits, how many unused combinations we are having from previous one? 63 into 2 power 7. 63 into 2 power 7. Can you calculate how many maximum one address instructions possible? Can you calculate how many maximum one address instructions possible? I am calculating. It is 8064. 8064 maximum one address instructions possible, not more than that. Not more than that. इससे ज्यादा one address instructions possible नहीं हो पाएंगे. So if somebody asks me in this particular question how many one address instructions are possible, then I am having a range. I am having a range for one address instructions. I am having range for one address instructions. Key number of one address instructions can be, okay, let me make it like that way. Number of one address instructions can be minimum 1 to maximum 8064, not more than that. मिनिमम 1 क्यों? क्योंकि एक तो चाहिए ही चाहिए. मिनिमम 1 होता है, मैक्सिमम 8064. सो which is possible one address instruction? 0 possible, never possible. 0 कभी भी possible नहीं हो पाएगा. याद रखें, if question says two address and one address instruction supported, means at least one of that type instruction needed. At least one of that type instruction needed definitely. बिल्कुल जरूरत है. समझ गए? Did you understand that or not? If you understood, then 0 is not possible. Of course, 8065 not possible. Why? Maximum is 8064. 8192 तो definitely not possible. Only one possibility is there, D. कि 128 one address instructions are possible. Any number between 1 to 8064 possible. Any number between 1 to 8064 possible. Got it? अगर आपको ये चीज समझ में आई है तो जल्दी से कंफर्म कर दो, तो आगे बढ़ेंगे हम और अगला क्वेश्चन सॉल्व करेंगे. Come on. Yes. Only D is possibility. Okay, clear, cool. Let's go for another question. Here it is, another question in front of you. Question number 17. हमारे हिंदी में, हमारी तरफ एमपी में बोलते हैं 17 मतलब खतरा. अरे इतना भी टफ क्वेश्चन नहीं आएगा. Very simple question it is. Consider a PC relative branch mode type instruction stored in the memory at address 250. So in the memory there is an instruction stored, and that at address 250. So there is an instruction which is using PC relative type mode on address 250. Got it? Now next is what? The relative address field contains value 200. So in the instruction we know key address part has value 200. Fine. Now which of the following is possible PC value immediately after execution phase of the branch instruction execution? Okay, so if this is PC relative branch type instruction, it is stored here on this address before instruction fetch. Okay, so before instruction fetch of the same instruction, my PC value should be 250. Fine. 250. Fine. Now, listen. After instruction fetch, the PC value will be incremented and becomes 251. Becomes 251. Fine, cool, clear, understood. Now we will calculate the target address in the effective address calculation phase. Target address will be calculated by current program counter value, which is 251 plus address field value 200, and it becomes 451. It becomes 451. Now listen, I told you we have calculated the target address, but in the question there is no any mention that we need to take the branch. Is there any statement written in the question that says कि branch is taken? No. Is there any statement it says that branch is not taken? No. Both possibilities are there? Yes. So two possibilities we have here for the branch instruction, and the possibility is branch not taken और ब्रांच टेकन. दोनों पॉसिबिलिटी बनेगी यहां पे. अगर दोनों पॉसिबिलिटी बनेगी तो दो अलग अलग वैल्यूज ऑफ पीसी वी कैन हैव. इफ ब्रांच नॉट टेकन देन पीसी विल रिमेन सेम. PC will remain same 251, and if branch is taken, PC will be updated by target address 451. PC will be updated by 451 only in the case when the condition is true. If the condition is false, then PC will not be updated. It will remain 251. So there are two possibilities here कि branch taken or not taken. Condition is true or false. Right? Right. So for this question, we will be having two answers. Apart from your expected result, B and D are correct answer. You expected only 451. You know why? Just because you think it like that way. Branch है तो सर हम तो जंपेंगे, हम तो जंप करेंगे ही करेंगे. No, there is no any true or false condition written in the statement, or there is no any statement which says that you need to take the branch, you need to take the jump. That is not given. So are you guys fine till now? Are you guys fine till now? You want a breather? Or should we go for the next question? You want a little bit breather? हाँ सर, सांस तो ले लेने दो. इतना ज़्यादा tough, इतनी सारी चीजें, so many things to recall. We are not able to recall every single thing. Oh ho. Tough. This is what I want you to feel now only, so that in the GATE exam, when the 3 hours you will be sitting non-stop, I would like you to have the maximum concentration on those 3 hours. You need to have lot of concentration. That's my own personal experience. Ki even though now also, if I have written the GATE exam, just 2 years back only I have written. So when 2 years back I have written the GATE exam, though no any pressure was there on my head, but still when I have written the GATE exam for 3 hours with more concentration, my entire head was burning like anything. Too much of heat produced in my head just because I was using it non-stop constantly. And that you need to learn now only. Yes, put concentration on one particular thing a lot, so that you will be not doing any kind of silly mistakes. Learn it. Learn that method to solve the questions for non-stop 2 hours, 3 hours, 2 hours, 3 hours, like you are writing a GATE exam, so that you have a comfortable environment in your mind कि yes, I can do it. Otherwise, after 2 hours, आप बोलोगे अरे मेरा मन नहीं कर रहा, अब मेरे को सॉल्व नहीं करना. सर अब मेरे को सॉल्व नहीं करना, अब मेरे को सॉल्व नहीं करना. ऐसा एग्जाम में यू माइट हैव फेल्ट इन योर यूनिवर्सिटीज एग्जाम्स टू मच. सर अब 2 घंटे 2.5 घंटे इतना लिख दिया था कि मेरा तो मन ही नहीं किया लिखने का. होता है, हुआ है कभी ऐसा? अरे गेट एग्जाम में ऐसा नहीं कर सकते. सो इफ यू आर नॉट रेडी फॉर दैट पर्टिकुलर 3 hours of highest level of pressure situation, then make yourself ready by solving the questions, by writing the test for very highest level of concentration. Okay, another question number 18. Here it is in front of you. Consider a system which supports 30-bit instructions. Okay, fine. 30-bit instruction. Let me draw. Here it is. The system supports 45 one address instructions. So number of instructions are 45. If number of instructions are 45, then from here you can calculate opcode bits. You can calculate opcode bits, yes, based on 45, log of 45 base 2. Its seal value 6 bits I am getting. 6 bits will be required for opcode to support 45 instructions, right? One address instruction means you will be having in the instruction one opcode and you will be having in the instruction remaining bits for address. So total 30-bit instruction and address is, I don't know, right now opcode is 6, address will be of 24 bits. What is the question? Which of the following is or are possible size of memory supported by the system? So based on this, if address size is 24 bits, then maximum size memory supported by the system is equal to 2 power 24 bytes. 2 power 24 bytes maximum size memory supported. This is the maximum size memory just because using 24-bit only CPU can generate the addresses. 24-bit addresses only CPU can generate. Now listen. If 2 power 24 byte, which is nothing but 2 power 4 is 16, 2 power 20 is mega, 16 megabyte is the maximum size memory supported. This is maximum. Lesser than that, yes, chalega. से ज़्यादा नहीं possible है. More than this will not be possible. More than this will not be possible, which means 1 KB memory supported, yes. 1 MB supported, yes. 16 MB supported, yes. 64 MB will not be supported. 64 MB will not be able to support. The system will not be able to support this. So A, B, C is the correct answer. Got it? Got it? Got it? The same question can be asked in a NAT. NAT, yes. Which of the following, or instead of which of the following, they may write that maximum possible memory size supported by the system is dash 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 megabytes. Same question, NAT type. Same question, MSQ type. Only difference is understanding of the concept. If you understand the concept, any type of question you can make from out of same type of solution. Good, got it, amazing. Next question. Another question, question number 19. अभी तक 19 पे ही पहुंचे यार. 60 question कब solve होंगे? Let's see. Which of the following is or are true for the system which supports variable length instructions? Variable length instruction. Instruction fetch cannot happen in one time. Possible. Why? Just because variable length instruction is there. In that case, first of all, CPU just fetches the opcode. And after that, CPU understands based on this opcode, what can be the maximum possible size of instruction. And after that, remaining instruction will be fetched. So in the variable size instruction, when CPU is tuned, CPU doesn't know initially that next instruction can be of what size. CPU first fetches only opcode. CPU prefetches an opcode and understands what type of opcode this is. Based on the initial analysis, initial decode, CPU understands, okay, this opcode, this operation, this instruction can be of this much size, then remaining instruction will be fetched later. So might possible instruction fetch cannot happen in single time. It's a true statement. A decode is needed to fetch complete instruction. Yes, अभी तो मैंने समझाया कि हो सकता है fetch करने के लिए instruction को एक अलग से decode लगे. बिल्कुल. In first time only opcode and or are addressing modes is or are fetched from memory. Yes. पहले स्टार्टिंग पार्ट ऑफ इंस्ट्रक्शन लेंगे, फिर चेक करेंगे उसे. वी विल चेक इट आउट कि इफ दैट पर्टिकुलर इंस्ट्रक्शन रिक्वायर्स मोर बाइट्स टू बी फेच्ड, यस, देन वी विल फेच लेटर. एवरेज इंस्ट्रक्शन फेच टाइम फ्रॉम सीपीयू इंक्रीजेस. माइट पॉसिबल करेक्ट. ऑल दीज आर करेक्ट. ऑल दीज आर करेक्ट. बिल्कुल सही है. सारे के सारे करेक्ट हैं. ए, बी, सी, डी सारे करेक्ट हैं एक पर्टिकुलर वेरिएबल लेंथ इंस्ट्रक्शंस के लिए. Another question. Question number 20. We have reached to the first milestone, 20th question. Okay. Disadvantage of having fixed length instruction support in CPU is or are. Disadvantages. Okay. Disadvantages of having fixed length instruction. If length instruction is fixed, what are the disadvantages? Large size memory required for program to be stored. Yes, possible. Why? You know why? Just because suppose if you have fixed that the instruction is of 32 bits always. Sometimes you need only opcode in the instruction, but remaining bits will be empty. But then too you need to store those as padded bits or extra bits. Why? Just because you need to keep the instruction length fixed. In that particular case, to store complete program of only 32-bit instruction, of course the large size memory is required. Average instruction fetch time is increased. Yes, of course. Why? Just because every time instruction will be of large size, fixed size, average instruction fetch is increased. If we will allow the variable length instruction, why we allowed variable length instruction? So that if any instruction does not require any field, if any instruction does not require any information, we will reduce the size of instruction. That is what the advantage of variable length instruction, and disadvantage of fixed length instruction is opposite one. Average instruction fetch time is increased. Yes. Whole instruction can be fetched in one time. Yes, that is the advantage. That is the advantage, not the disadvantage. Okay. This is true statement for fixed length instruction, but it's not a disadvantage. It is not a disadvantage. So it's an advantage. Now next. Sometimes address part of instructions does not contain any useful information. Yes, that is true. And again disadvantage. यही तो बताया था मैंने कि address part में कुछ भी नहीं, पर फिर भी उसे रखना पड़ेगा. Why? Just because we are having the fixed length instruction. So A, B, D are disadvantages of the fixed length instruction. Statements all are true. All statements are true for a fixed length instruction, but disadvantages are only A, B and D. Okay, got it. So previously starting few questions, 10 questions we have seen from mixed, 10 questions now we have seen from basic instructions and CPU and all. Now we are going to see next some 8 to 10 questions from CPU chapter. Yes, from CPU chapter. CPU can perform what in a CPU cycle? In one CPU cycle, what CPU can do? So we will one by one cover. After this, we are going to have some questions from memory organization, then some questions of cache organization, some questions on pipeline, some questions on IO organization also we are having. Let's see what is next. A CPU can perform what in one CPU cycle? Can CPU perform a micro operation in one CPU cycle? Yes. One instruction execution? Yes. In the RISC computer systems, in RISC type of computer system, in one cycle, one complete instruction is executed. One complete instruction is executed. One DMA operation? No. CPU does not perform DMA. Na? CPU does not perform DMA. DMA is performed by DMA controller. CPU does not do it. So CPU can perform one micro operation in regular CISC type of systems. In the RISC types of systems, the one instruction execution is done by CPU in single cycle. So A and B both are correct. A, B correct. C नहीं. एक DMA ऑपरेशन, अरे CPU DMA करता ही नहीं, DMA कंट्रोलर करता है, तो CPU क्यों परफॉर्म करेगा? क्या एक घंटे में आप 100 कैट के क्वेश्चन सॉल्व कर सकते हो? बोलोगे सर हम केट के क्वेश्चन क्यों सॉल्व करने जाएंगे? क्या आप एक आवर में बैंक एग्जाम के क्वेश्चन सॉल्व कर सकते हो? सर हम तो गेट की तैयारी कर रहे हैं, हम बैंक एग्जाम के क्वेश्चन क्यों सॉल्व करने जाएंगे? सिंपल सी बात है, आपका काम ही नहीं तो आप क्यों करोगे? आपका जो काम होता है वो भी कहां करते हो, जो नहीं है वो तो डेफिनेटली नहीं करोगे. जो मैं सोचता हूं वो बिल्कुल नहीं करता, और जो मैं सोचता नहीं हूं वो तो करने का सवाल ही नहीं होता. आगे बढ़ो. क्वेश्चन नंबर 22. अनदर क्वेश्चन. A CPU cycle time is 2 nanosecond. Fine. CPU supports 16 types of instructions. Fine. If instruction type I1 takes 6 nanoseconds for execution and instruction I2 takes 10 nanoseconds for instruction execution, then average CPI of CPU can be what? CPU cycle time is 2 nanoseconds. I1 instruction is taking how much time? 6 nanoseconds. Means how many cycles? 3 cycles. I1 type is taking 3 cycles. I2 taking 10 nanoseconds. Means how many cycles? How many cycles? How many cycles? How many cycles? 5 cycles. Why? How can I say 3 cycles and 5 cycles? अरे cycle time दे रखा है ना 2 nanosecond का. 2 nanosecond 1 cycle time. 2 into 3 total 6 nanosecond is time for execution for I1. I2 का execution time 10 nanosecond. Now only about 2 instructions, given that this is 3 cycle CPI and this is 5 cycle CPI for I1 and I2 time. Now the question is, average CPI for entire CPU can be. I cannot calculate average CPI only based on 2 instructions. Based on 2 instructions, we cannot take the CPI. We cannot calculate the CPI. So what happens in that particular case? CPI can be 3, can be 4, can be 6, can be 2. I don't know, just because we don't have appropriate answer to be calculated based on the given scenario. So it can be 3, 4, 6, 2, anything. All are correct answer. Can be A, B, C, D, any value. Yes, कोई भी value possible है किसी एक CPI के लिए, एक CPU के लिए. I need more information. All type of instructions, their regular cycle, average number of cycles for that particular instruction, and their count also. How many number of instruction of that type we are executing. Based on that, we can calculate the average CPI. If you don't know how to do that, check it out in my CO playlist. Go to the channel, same channel. There is a playlist of 52 lectures. In that particular COA playlist, you will get this particular calculation in very first chapter, or very first lecture of CPU chapter. Okay. If you got it, next question. Here it is. Clock rate of CPU is 0.5 gigahertz. Fine. So 0.5 gigahertz means one cycle the CPU takes. One cycle time is 1.5 gigahertz. Sorry. So one cycle time will be how much? Can we say 2 nanoseconds? 2 nanosecond is one cycle time. The time required to perform an operation in CPU can be. So CPU can take one cycle to perform an operation. Yes. Can take 2 cycles to perform an operation. Yes. 3 cycles. Yes. 4 cycles. Yes. So one micro operation, CPU can take one cycle. Might possible some operations may require more than one CPU cycle. Bilkul. Might possible if CPU is accessing hardware, outside hardware like memory or some other IO or something, CPU may require 2 cycles, 3 cycles, 4 cycles, 5 cycles, some number of cycles, right? So in that particular case, in 1 nanosecond, CPU cannot perform operation, just because at least 2 nanosecond, one cycle is required. So B is correct. C is also wrong. Why? Just because 1.5 cycle CPU will not take. CPU will take either 1 cycle, 2 cycle, 3 cycle, 4 cycle. So CPU will be tuned in the cycle. CPU either will take 1 cycle or 2 or 3 or 4 or 5 or like this. So CPU will take 4 nanoseconds. Yes, possible for one operation. Yes. So B and D will be the correct answer. all the members who have joined little late, जिन लोगों ने बाद में ज्वाइन किया है, उनसे एक छोटी सी रिक्वेस्ट है, अगर आप लोगों ने सेशन को लाइक नहीं किया है तो लाइक कर दीजिए एंड शेयर कर दीजिए अपने फ्रेंड्स के साथ में, सो दैट दोस पीपल आल्सो कैन ज्वाइन अस. नींद नहीं खुलेगी उनकी, बट ये क्वेश्चन देखने के बाद डेफिनेटली खुल जाएगी. डेफिनेटली ये क्वेश्चन देखने के बाद उनकी नींद खुल जाएगी. अगला क्वेश्चन, क्वेश्चन नंबर 24. आई विल गिव यू अ लिटिल बिट एक्स्ट्रा टाइम फॉर दिस क्वेश्चन. ट्राई टू अंडरस्टैंड एंड सॉल्व द क्वेश्चन. CPU cannot perform two micro operations simultaneously always because CPU is not that faster. No. Components inside CPU like ALU, registers, mux, decoders are not capable. Capable. At a time, components can perform only one operation. Yes. At a time, one component can perform only one operation. That's why two micro operations cannot be performed simultaneously because of memory access delay. Na? Memory access का क्या ही case है? Only C option is correct. Two micro operations cannot be performed. Why? Just because components can perform only one operation at a time. That's it. Next one, MIPS. Another question is regards to MIPS. Another one. Which of the following is true regarding MIPS? It is good metric to compare two processor? No. It may give you false results. If you have watched my lectures, I have clearly mentioned this in all the lectures that MIPS is not a good metric to compare two processor just because MIPS count may be decisive. A CPU which is having more MIPS count can be very simple processor, and a complex processor which is executing very complex instructions can have a lower MIPS count. It is calculated based on CPU's clock rate. Yes. It is calculated based on CPI. Yes. Calculated based on instructions complexity and capability. No. There is no any instructions complexity and capability included in the calculation of MIPS. If you remember the formula of MIPS का formula होता है, remember that CPU's clock rate divided by average CPI into 10 to the power 6. So B and C are the true. Good, amazing, nice, superb, बहुत बढ़िया यार, बहुत amazing. अगला क्वेश्चन ये रहा, क्वेश्चन नंबर 26. Control unit generates control word so that register to register data transfer can be performed. Yes. So control unit actually generates the signals so that any operation can be performed in the computer system. Okay, so register to register data transfer can be performed. Yes. Condition can be evaluated for branch. Yes. Memory write can be performed. Of course, yes. ALU operation can be performed. Yes. For every single operation in computer system, the control unit generates control signals. Control signal are generated based on that only operations are performed in computer system, whether it is ALU operation or it is a data transfer operation from one place to another place, or whether it is memory access operation or any kind of operation. So all A, B, C and D are correct. Got it. आगे बढ़ें क्या? आगे बढ़ें. अगला प्रश्न ये रहा आपके कंप्यूटर स्क्रीन पर, जो आपको दे सकता है कुछ अच्छा experience or knowledge. In horizontal microprogrammed control unit, the timer is reset after. So if you remember, in horizontal microprogrammed control unit, is there any timer? No. There is no any timer at all in the horizontal microprogrammed control unit. It's a trick question I made. In the horizontal microprogrammed control unit, you don't have timer. You have timer in hardwired control unit. You have timer in hardwired control unit, but not in horizontal microprogrammed control unit. So there is no any set reset of timer in the horizontal microprogrammed control unit. There is no any timer in the horizontal microprogrammed control unit. Microprogrammed control unit will not have timer. The timer will be there in hardwired control unit, so that once an instruction is completed, then timer will be reset so that another T1, T2, T3, T4 timing signals can be generated. So all options will be wrong in this case. No any option is correct. It's a trick question I made so that you can understand कि horizontal microprogram से यार horizontal में हाँ every instruction सर ने कहीं तो बोला था कि एक instruction के बाद में वापस से timer reset होता है and you will be tricked. Okay, got it. Next question. Advantage of horizontal microprogrammed control unit is no use of signal decoder. Yes, it can be an advantage. Yes, because it does not require any signal decoder. Faster than vertical microprogrammed control unit. Yes. Faster than vertical. Okay, नहीं vertical नहीं है यहाँ पे. Faster than nano programmed control unit. Yes. Larger sized control word. See, this statement is true, but that is not the advantage of horizontal microprogram control unit. See, these are the small things we should understand. We are trying to get the advantages of horizontal microprogram control unit. We are not getting the statements which are true or false for horizontal microprogram control unit. We are just calculating advantage. We are just trying to get the advantages. This is not the advantage. ये कोई advantage नहीं है. A, B, D are the correct answer. Sorry, C, not D. D is wrong. C, A, B, C are the correct answers. Okay. If you guys are clear about this, can we go for the next one? Can we go for the next one? Next one is here. Which of the following is or are the characteristics of a RISC processor? RISC processor में क्या characteristics हो सकती हैं? Simple instructions? Yes. Less number of addressing modes? Yes. More number of CPU registers? Yes, registers are more. Register to register arithmetic operations only? Yes. All are correct. A, B, C, and D all are correct. All are correct in the RISC processors. Got it. Next. Another question. Now we are starting the memory organization. Okay. Memory is represented as. How the memory is represented? A cross B, where A is number of memory locations and B is number of bits in each location. Yes, correct. Total number of locations cross bits on each location. 2 power A cross B, where A is number of bits and B is number of bits in each location. Okay, so I can represent memory as this way also. 2 power A cross B. A is size of address, yes, number of address bits. So total number of addresses will be these many into B, number of bits in each location. So this is also fine. B cross A, where number of bits in each location first, nahi. Pehle number of location you need to write. This is wrong. Next, 2 power D cross B, where D is the data bits. There is no any 2 power D we are going to calculate for the memory access or for the memory representation. Not at all. So only A and B are correct. Is that clear? Cool, everybody? Can we go for the next question? Another question. Here it is in front of you. Here it is, question number 31. So halfway we are down, halfway still remaining, and we have only 1 hour to complete halfway. It's okay. If we will not be able to finish it today, we can have another small session to cover it. But definitely somehow we will cover all these 60 questions somehow. A memory has 16-bit address bus. Then how many memory locations are there in the memory? If 16-bit address bus means you can have number of memory locations is equal to 2 power 16. 2 power 16 locations. 2 power 16 means 64k. 2 power 6 is 64. 2 power 10 is k, or it can be 65536. So A is correct, B is correct, C is correct, D is wrong. It's 16,000. It's For us, it is 65536. So A, B, and C are correct. Great, 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 great. Great, amazing, 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 amazing. Nice, nice, super. बहुत सारे लोग, so many members are able to give the answer. Super. Piyush Kumar, Mayuri, Ankit, random stuff. Parvej, Subhashri, Jay, Samir, nice, amazing. Super. Talha, amazing. चलिए, next question. Question number 32. Here it is. A processor uses a memory of 4 GB capacity. 4 GB capacity. Total. Okay. Total capacity is given. Possible address bus size is or are. Now listen, 4 GB is the total capacity size. If we have the one location, at one location, if we have 1 byte, if we have one location, 1 byte means byte addressable memory. Byte addressable memory, then it will be 2 power 32 cross 1 byte kind of memory representation you can have. 2 power 32 cross 1 byte memory representation we can have. Yes, in that particular case, address size will be what? Address size can be 32 bits. Address size can be 32 bits. Now suppose if cell size or at one location, at one address, if we are having 2 bytes stored, this is byte addressable memory, this is word addressable memory. This is word addressable memory. If we have a word addressable memory like this way, one location is 2 bytes, then in that case you need to write it like this way, 2 power 31 cross 2 bytes, total, 2 power 31 cross 2 bytes, total 2 power 32 bytes. In that particular address, in that particular thing, address size will be 31 bits. You might have, this is the first case, this is the second case, third case is you might have word addressable memory of like this, 2 power 30 cross 4 bytes. In that particular case, address size will be what? 30 bits. Can we have at one location 4 bits are stored? Can we have instead of 1 byte or 8 bits at each location, can we have 4 bits stored on a location? Can it be possible? Can we have a memory like this way, 2 power 33 cross 4 bits? Can we have a memory like that way? Can we have a memory like that way? पॉसिबल, यस पॉसिबल, बिल्कुल पॉसिबल है, बिल्कुल पॉसिबल है. वी कैन हैव लाइक दिस वे, 2 power 33 from here. If you will take 1, 2 power 32 into 2 into 4 bits, which is 2 power 32 bytes. It is possible, yes. In that particular case तो address size और 33 bits भी आ सकता है. Yes, we can have. Yes, possible, we can have. The minimum possible size at each location can be 1 bit. You can store in a memory on each location 1 bit. इससे 1 बिट को तो आप और ब्रेक नहीं कर सकते. 1 बिट से तो और ज्यादा ब्रेक नहीं कर सकते. Of course, it will not be efficient, but at least you can keep it. You can keep it. Possible, of course, possible. Of course, possible. So I am writing that statement here at each location. At each location, minimum size data can be 1 bit, can be 1 bit. So in that particular case, what happens? So there is no any mention here in the question that it's a byte addressable memory. Only one thing is given, that 4 GB capacity in total the memory is used. In that particular case, we can use minimum size data 1 bit also. How will you represent that particular memory? In this particular case, you will be writing 2 power 35 cross 1 bit. So we can say maximum address size we can have is 35 bits. More than that not possible for this 4 GB capacity memory. So for that, option A, B, C, D all are correct. All are correct. So those are very, very specific memories. If you don't know about this, then 4-bit content is called as a nibble. Nibble, I guess. Spelling you can check it out, but it is called as nibble. 4-bit content is a nibble. So nibble addressable memory you can call it as, or a bit addressable memory you can call it as, if for 1 bit is storing you are on the single location. Okay. So remember that it is possible. We can have a memory in which on a location we are storing 1 bit only, or 2 bits only, or 4 bits only. 8 bits to it's a byte. So all 4 options are correct for this particular question. Okay, let's go for the next one. Which of the following is or are true? When CPU is restarted, then CPU executes instruction from ROM. Yes, that's true. OS programs are always stored only in RAM in computer system? No. OS programs are always stored in only in RAM in computer system? No. It can be stored in hard disk also. During booting, user interaction with the system is almost zero. Yes. Booting के time पे आप तो कुछ नहीं करते. Once the OS programs start executing in CPU, after system start, then access of ROM is not needed till next restart. That is also true. When the operating system programs started executing from the RAM programs or RAM memory, then after that CPU will not go for ROM access. For ROM access, if you want, then you need to restart the system. At that time, starting of the system only, we will need the ROM memory. So A, C, D and are the correct answer. A, C, D are the correct answer. OS programs always stored only in RAM? No, it can be stored in the hard disk also. In the main memories, among the main memories, अगर ये question पूछा होता, OS programs stored only in the RAM, in the computer systems, among all the main memories, yes, it can be correct answer. It can be correct answer. So B is wrong. B is wrong. B is wrong. B is wrong. Okay. Now next question. Question number 34. अभी थकना मना है. अभी तो halfway ही पहुंचे हैं. We need to solve so many questions, dear. So if you want, you can take a tea. You can take some water. You can take some stretching like that way, this way, and then again come back. Come back means mentally come back and solve the questions. Next question. Which of the following is or are not true about main memory? Main memory. Okay. It is directly accessible from CPU. It is true. It is true. It is true. And they are asking about false statement. Needs interface for interaction with IO. Main memory needs interface for interaction with IO. Yes, that is also true. IOs can send data to cache directly? Yes. CPU generates addresses always for main memory? Yes, that is also true. So, is there any statement which is not true? All are false. All are true. All are true. All are true. All are true. Yes, directly accessible from CPU. Needs interface for interaction with IO. Yes, of course. If you remember, memory and IO interaction can be done using an interface which is called as DMA controller. So all are true. None is false. All are true. All are true. Not true. If you'll be going for not true, then wrong. Okay, no any statement. All are true. Another question. Question number 35. Statement. False statement. You need to check it out. Static RAM is used when the memory size requirement is larger. No. Small size is used wherever static RAMs are used just because it's faster and costlier. Cache memory के implementation में we use this static RAM. Another one. DRAM is volatile and needs refresh for data persistence. DRAM is volatile. DRAM is volatile, yes, and needs refresh for data persistence. Yes, that is true. Right? DRAM can be used for read-write during refresh of cells. No. एक refresh के time पे you cannot perform read-write. DRAM is used when the memory size requirement is very small. False. So only B is true, A, C, D are false. Got it? Got it? Fine. Which of the following is or are not false? Okay. Associative memory, not false means true. Associative memory is faster than SRAM. Yes, that's true statement. In associative memory, cells do not have addresses. Yes, cells do not have addresses. We search into the associative memory based on content. Searching time in associative memory is very less because of multiple matching logics. That is also true. TLB can be implemented using associative memory, but cache cannot be. No, both can be implemented. This also yes, and this also, cache memory also can be implemented using associative memory. So A, B and C are correct answers. Are you guys understanding the solutions or not? आप लोगों को solution समझ में आ रहे हैं या नहीं? Yes or no? चलिए बढ़ते हैं आगे. अनदर क्वेश्चन नंबर 37. अभी तो बहुत सारे क्वेश्चंस बचे हैं, बहुत सारे क्वेश्चन बचे हुए हैं. अभी थकना डरना मना है. इट्स अ वेरी लॉन्ग सेशन आई हैव केप्ट फॉर यू गाइज सो दैट सिंगल सेशन, एवरीथिंग इन सिंगल सेशन ओनली. डन 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 डन. आगे बढ़ते हैं. विच ऑफ द फॉलोइंग स्टेटमेंट इज और आर ट्रू? कौन सा स्टेटमेंट ट्रू है? इफ सिलेक्ट लाइन इज इनेबल्ड देन बाय डिफॉल्ट रीड ऑपरेशन इज परफॉर्म्ड इन रैम चिप. नो. किसने बोला? Can be performed read or write depends on the signal, कि which signal is enabled, read or write. If select line is disabled and write signal is enabled, no operation is performed in RAM chip. Yes, that's true statement. If select line is disabled, then chip is not selected. Whether any operation signal is enabled, RAM chip will not be able to perform any operation. So operation will be performed only when the select line is enabled and any special signal is enabled, read or write. Chip select signal is used to select a specific cell within the RAM row. No. It is just to select the chip, not a specific cell. One chip select signal can enable more than one chip in the memory system. Yes, possible in the horizontal arrangement of the chips. In horizontal arrangement of the chips, it is possible. In the horizontal arrangement of the chips, possible. Chip select signal is used for chip select, not the cell select. Okay, so C is wrong, A is wrong, B and D are correct. B and D are correct. Okay. Next one, another question. Question number 38. A 32-bit wide main memory of size 8 GB is formed using A cross B bits DRAM chips. Which of the following is all true regarding the memory system? First of all, 32-bit wide. 32-bit wide means on each address, the requirement is to be stored 32 bits. Or I should say 4 bytes. Fine. And now the main memory size is 8 GB means 8 gigabytes divided by 4 bytes, which is like 2G. number of addresses. So CPU's requirement is to have a memory system 2G cross 4 byte. 2G cross 4 byte का requirement CPU has. CPU will generate 2G addresses, and on each address CPU requires 4 byte का data. Now that is formed using multiple chips of size A cross B. Further, which of the following is or are true regarding the memory system? Okay, a chip are arranged in 4 cross 4 if 128M cross 8 bit chip is used to form the memory. So option A, let's check. If 2G cross 4 byte we need the memory system, and we have 128M cross 8 bit ka one chip, what will be the number of chips and arrangement? So 4 byte is 32 bits. 32 divided by 8, 4 into 2G is 2 power 31, 2 power 27, 2 power 31 divided by 2 power 27 is 2 power 4, which is 16. So this will be the number of chips and arrangement required. For option A, it's wrong. Option B, 16 number of byte addressable chips are required, each of 512M mega cells. Okay, option B says कि if we have 2G cross 4 byte का total capacity and one chip is 512 mega cross 1 byte, then how many chips are required? 16. Let's calculate. 4 here into 2G is 2 power 31. This is 2 power 29. 2 power 31 divided by 2 power 29 is 2 power 2, which is 4. Yes, 16 chips are required. B option seems correct. Chips are arranged in 16 cross 4 if 128 cross M cross 4 bit chips are required. No, 128M cross 8 ke liye we were having 4 cross 4. Now let's check out for option C. Option C says if we are having 2G cross 4 byte is the maximum capacity divided by 128 mega cross 4 bits, then the chips will be from here to here you will be having 8 cross 16. 16 cross 8, no, wrong. 5 cross 32 decoder is needed if 64M cross 16 bit chips are used. ओहो, इसके लिए तो एक पेज लेना पड़ेगा. So we have 2G cross 4 byte का capacity total divided by 64M cross 16 bits. 16 bits means 2 bytes. Can I write 2 bytes? Yes. So it will be 2. And this will be 2 power 31 divided by 2 power 26, which is 2 power 5 cross 2 means 32 cross 2. This is the arrangement. Arrangement is like this, means you will be having 2 chips in horizontal arrangement, and such kind of how many vertical arrangements you will be having? How many? 32. If the chip arrangement is this, then of course you need a decoder. Of course, you need a decoder of size what? 5 cross 32 decoder. Each output will select one particular horizontal arrangement. So yes, this option is correct. D is the correct answer. D is the correct answer. Now the thing is, you need to understand such kind of question. This is very tough question, of course, just because it requires you to solve 4 different questions, but you need to understand how to attempt such questions so that you can solve such questions and get the answers. Another question number 39. Maybe it can be easy. Which of the following is or are not false? Not false means true. Regarding cache memory, it is mostly implemented using SRAM chips. Cache memory mostly implemented using SRAM chips? Yes. Cache is always organized in blocks of multiple bytes? Yes. Cache implementation is based on locality of reference concept? Yes, true. In case of cache miss, only main memory is accessed always. In case of cache miss, only main memory is accessed always. Is it? No. Might possible. might possible you may have virtual memory environment. In that particular case, if main memory also have not having the required page, then you might go to the hard disk. आप हार्ड डिस्क तक जा सकते हैं। कैश मिस के टाइम पे ओनली मेन मेमोरी इज एक्सेस, नहीं ऐसा नहीं है, आप हार्ड डिस्क भी एक्सेस कर सकते हो, वापस कैश मेमोरी भी एक्सेस कर सकते हो। व्हाई? जस्ट बिकॉज might possible you may bring a block from main memory to cache memory, again cache is access, तो only main memory is accessed, ये only word गलत सिद्ध कर देगा, इसको गलत प्रूव कर देगा इस particular statement को। So it's a false statement, we will go with A, B and C. Yes, correct. Okay, got it. So you guys are learning a lot. You need to bring every single possible knowledge of your entire content, whichever the course is, into solving the questions. Then only you will always get the correct answers. Okay, another question number 40. Here it is. Which of the following is or are false when there is a miss in cache? Miss के time पे क्या false हो सकता है? Missed block is transferred from main memory to cache memory always? No. If we have write no allocate system, it is possible that there is a miss in cache, but we are not bringing the block into the cache memory. It is possible that when there is a missed block is not transferred from main memory to cache. Always it is not possible. In the cache, no write allocate, there is possibility that we don't bring the block from main memory to cache memory. The requested byte or word is directly sent to CPU from main memory. Yes, it happens. That is true. Always a block is replaced from a cache for a new incoming block. No. Might possible you have empty space and you are just bringing in a new block. Access time for memory is more. Yes, that is true. Why? Just because if there is a miss in cache, of course you will be going for main memory access. So access time for memory system will be more. So it is A statement is false, C false. Answer is A and C. A and C. Yes, correct. Okay, fine. Let's go for the next thing is this one. If the cache access time is 10 nanosecond and main memory access time is 60 nanosecond, 60, cache hit ratio is 80%, then in this scenario, average memory access time for such memory system can be cache access time 10 nanosecond, fine. Main memory access time 60 nanosecond. So this is TCM, this is TMM. Hit ratio 80%. Average memory access time can be what? So you can have, if you are going with the regular solution, you may have two types of accesses, simultaneous and hierarchical access. So if you are going with simultaneous access, then your T average will be what? Can you calculate? T average will be what? T average will be 80% time 10 nanosecond plus 20% time 60 nanosecond, which is 8 plus 12, 20 nanoseconds. If the access is hierarchical access, in that particular case, T average will be what? In that case, T average will be 10 plus 0.2 into 60, which is 22 nanoseconds. So it might possible that you may go with option A and B. If this particular question will be asked in a NAT type question, then I will surely go with only 20 nanoseconds. Only 20 nanoseconds. You know why? Just because in this particular question, I would like to go with the simultaneous access. There is no any word hierarchy or level mentioned in this particular question. That's why I can go with the simultaneous access if NAT type of question will be asked for this one. Fine. So all the possibilities we can have is 20 nanosecond time or hierarchical access 22 nanosecond. Question number 42. Which of the following can be possible main memory access time if cache has 100% hit ratio with cache access time 10 nanoseconds? So, TCM is given as 10 nanoseconds and hit ratio of the cache is given as 100%. Question is asked, TMM is what? So we should understand that main memory should have more access time than cache memory access time. We should have main memory access time more than cache access time. So it can be 15, it can be 20. अब आप बोलोगे सर हिट रेशियो तो 100% है तो जीरो आना चाहिए. नाउ लिसन, इफ हिट रेशियो इज 100%, T average will be exactly cache memory का access time 10 nanosecond. T average will be 10 nanosecond, but main memory का access time तो रहेगा ना. If CPU is not accessing main memory, doesn't matter, but at least main memory will take some access time if needed. Yes, and it is 15 or 20. Why? Just because it should be more than cache access time. समझ आएगा? समझ आया क्या? समझ आया आप लोगों को या नहीं आया? समझ आया कि नहीं आया? So C and D are the correct answer for this particular question. Cool, 18 more questions to go. Let's go. When there is a write miss in cache, write miss means for the write operation there is a miss. What happens? Data bus carry only one byte or one word from main memory to CPU. Data bus can carry one byte or one word from memory to CPU. You just think, what is the write operation? Write operation means in the memory we are writing. In the memory we are writing means CPU will send the data for writing. Yes. So data bus will not carry a byte from main memory to CPU. No. CPU will send the data to memory. Data bus can carry a block from main memory to cache. Yes, possible. Yes, possible. How? If suppose write miss is there and we allocate or we have write allocate policy. Write allocate policy means what? Write allocate policy means you are bringing the block from main memory to cache memory when there is a miss. So might possible the data bus will carry a block from main memory to cache when you are going for write allocate policy. Data bus can carry one block from cache to main memory. Yes, possible. When you are bringing a block from main memory to cache and if the replacement happens. If the replacement happens, in that particular case, might possible that data bus will carry a block from cache memory to main memory. Possible. Write through and write back both will have same performance always? No. Write through will take more time in the write miss and write back will take less time? No. Opposite. Write through, in the write through, CPU is sending the byte to write in the cache, in the main memory. Written, and after that we see if write allocate is there or not. If write allocate is not there, that's it. That's it. So write through in the write miss can take less time. Why? How? Just because in the write through, if you are using the no write allocation, then we are not bringing the block from main memory to cache memory. We don't bring the block from main memory to cache memory. Go to the main memory, update the data, done. But in write back, we use the write allocate. So we need to bring the block from main memory to cache memory. That's why these two can have what? Different performance. B and C are correct. Okay, next question. Question number 44. Cache mapping helps in placing a main memory block into cache. Yes. Searching a main memory block into cache. Yes. Calculating number of cache misses for a specific program execution. Yes or no? How do you get hit or miss? Based on mapping. Based on mapping only you will check, search and check it out ki main memory block is present in the cache or not. Yes. So of course in calculating number of cache misses mapping can help. Placing a block from hard disk to cache, hard disk से cache में तो हम block लेके ही नहीं आते. So options A, B, C are correct. A and B and C are correct. Still 35 minutes left. 16 questions are left. Okay, 2 minutes per question still we have. So be with me. Don't go anywhere and stick to the this particular procedure of highest level learning. Okay, जाना नहीं है कहीं पे, कहीं नहीं जाना है, कहीं नहीं जाना है. Let's go for the next question. Question number 45. To calculate the size of tag, cache memory size and main memory sizes are sufficient in direct mapping. Yes, sufficient. Block size is not required. This I have covered in all type of classes, whether it is Plus or YouTube. Everywhere I have explained this. In fact, on the Unacademy special classes also I have explained. Using the cache size, you can directly calculate total number of bits in the block and byte offset, and based on that you can calculate tag size easily. Next, cache size and main memory sizes are sufficient in set? No. For set associative mapping, one more extra thing is needed, and that is associativity. Associativity भी चाहिए tag size को calculate करने के लिए, apart from cache size and main memory size. Cache size and main memory sizes are sufficient and fully. No, in the fully associative mapping we need the block size. Why? Just because in fully associative mapping we divide the main memory address into only two parts. Main memory address divided into two parts, tag and byte offset. So block size definitely needed to calculate the tag size in fully associative mapping. Number of blocks in cache and main memory are sufficient in fully associative mapping. Yes. If number of blocks are given in the main memory, then log of main memory or number of main memory blocks will give you tag size of the fully associative mapping. All these, ये सब मैंने करवा रखा है क्लास में. आपको सिर्फ और सिर्फ याद रखना है कि कैसे निकलेंगी ये सारी चीजें, और यही चीज होती है जो आपकी एग्जाम में आपको किसी से या तो ऊपर ले जा सकती है या आपसे किसी और को ऊपर ले जा पाएगी. These are the things which are required to be remembered so that you can solve the questions effectively, efficiently in the exam. And this is what needed for you guys. Remember the concepts. Remember the concepts. These are small things, but very, very important for you guys. Okay, another question. Question number 46. Consider a cache with 256 MB size. Okay, CPU generates 32-bit addresses. Fine. Which of the following is or are not possible values of tag in the memory address? So only cache size given, CPU's address size given. That's it. So CPU's address size is 32 bits. Fine. Block size given? No. Cache size given? Yes. Fine. So CPU's address size 32 bits means main memory address is 32 bits. Based on that, 256 MB. 256 MB means 2 power what? 2 power 8 and 2. 20. 28. 2 power 28 means this is 28 bits. In the direct mapping. For direct mapping, this is for direct mapping I am talking about. For the direct mapping, we can have how many bits of tag? For direct mapping, we can have how many bits of tag? 4 bits. 4 bits. 4 bits of tag we can have. Possible. Okay, fine. Now, next thing. If 4 bits of tag we can have in the direct mapping in set associative, two-way set associative, you can have a tag size of 5 bits. You can have a tag size 5 bits in set associative, two-way set associative mapping. 1 bit less in the in the index field and one more bit in the tag. Then for 4-way set associative, you can have 6 bits. You can have 7 bits for 8-way set associative. For next 16-way set associative, you can have more bits. So you may have more than 4 bits in the tag. Yes. For fully associative mapping, how much size of tag you can have? How much size of tag you can have? How much size of tag you can have for fully associative mapping? So for fully associative mapping, you may have like this tag and block size or byte offset, right? So if we have the extreme case when the byte size or when the block size is just 1 bit, in that case entire 32 bits you can include in tag. So you can have a tag size of 5 bits, you can have a tag size of 6 bits, you can have a tag size of 32 bits. Of course you cannot have more than 32 bits possible. More than 32 bits it is not possible. So you can have option A, B and C possible for all the tags for different types of mappings and block size and so on. Another question, अभी खत्म नहीं हुआ है ये, अभी खत्म नहीं हुआ है, अभी खत्म नहीं हुआ है. we can go further. अभी और आगे जाना है, अभी और आगे जाना है. half an hour remaining. 14 question more remaining. 14 more question remaining. Let's solve this particular question. What it says: size of following is or are true. Size of tag memory needed in cache controller is larger. Size of tag memory needed is in cache controller is larger for set associative cache as compared to fully associative cache. No. In the fully associative cache, the tag size will be more. If tag size will be more, then of course more tag size or tag memory is needed. So it's not true. It is not true. Next one. Size of tag memory needed in cache controller is smaller for direct mapped cache as compared to set associative. Yes. Just because in the direct mapped cache, you have minimum size tag. In the associative mapping and in the fully associative mapping, you will be having more size of tag. So tag directory size, tag memory size increases. Hardware requirements are more in set associative cache as compared to the direct mapped cache for hit miss checking. Yes. More number of multiplexers, more number of comparators and extra maybe multiplexers or OR gates are needed. Fully associative cache can have less misses as compared to direct. Yes, true. Just because it does not have conflict misses, because of that, fully associative cache will have minimum number of misses for a program as compared to the direct mapped cache. Okay, so these are the true statements B, C and D. When you increase the associativity, the miss, regular miss increases, no, decreases. Miss कम हो जाते हैं अगर associativity बढ़ाते हो तो आप. Fine. If one block is of 1 for block size, then 31. ओहो पीयूष, अगर एक बिट आप block size में लोगे तो 2 power 1 means 2 bytes का block आपके पास हो जाएगा. For 1 byte block 2 power 0, 0 bits will be required for byte offset. इसलिए सारी की सारी बिट्स यू कैन गो फॉर टैग. 2 power 0 is 1 रे बाबा. Which of the following is or are true? Von Neumann architecture is SISD type computer. बिल्कुल सही. SIMD are pipelined system. Yes. MIMD also pipeline system. Yes. Multiple pipelines होती हैं इनमें होती हैं multiple pipelines. MISD are very widely used. No, MISD यूज ही नहीं होता है. मल्टीपल इंस्ट्रक्शन सिंगल डेटा यूज ही नहीं होता है. नो एनी प्रैक्टिकल इंप्लीमेंटेशन ऑफ दिस टाइप ऑफ कंप्यूटर सिस्टम. Got it? So options A, B and C are correct. Fine. Let's go next. Next question. Still we are still left with 12 questions. Okay, so remaining time, whatever the time is remaining, you need to be stuck with me here only and don't go anywhere. Let's solve the questions. Which of the following is or are not false regarding the pipeline? Not false means true. For single input, non-pipeline is better than pipeline system. Yes, for single input, non-pipeline is better just because pipeline will have extra delays because of the synchronization. We provide the synchronization and then we provide the intermediate register delays and all. Because of that, pipeline system will not perform better for single input. Pipeline can be fruitful when multiple different processing is applied over multiple inputs. No, different nahi, multiple different, no, only single type of processing, same type of processing should be applied over multiple inputs, then only pipelining can be fruitful. Next, C option. Pipeline with single segment cannot provide parallel processing. Yes, that is true statement. To provide the parallel processing in the pipeline, we should have multiple segments. Zyada segment chahiye, multiple segments are needed, then only those multiple segments can perform parallelly some different operations on different inputs. That is why parallel processing is applied only when we will be having in the pipeline multiple segments. Non-pipeline system does not require intermediate register or buffer for synchronization. That is true. That is true. Not false true. Yes, not false true. A, C and D are correct for question number 49. क्या आप सहमत हैं अभी तक के आंसर से? आगे बढ़ सकते हैं? Okay, okay. Let's go for the next question. Question number 50. ये हमारी 50 हो जाएगी, half century complete हो जाएगी. Okay, you can clap, you can dance, you can say yes, I have solved 50 questions after this. But let's say next question. Question number 50. Here it is in front of your screen. 6-segment pipeline system in which segment delays are 32 nanoseconds, 34 nanoseconds, 20, 26, 38, 27. The pipeline uses intermediate buffers also every segment with 2 nanosecond. Fine. Which of the following can be possible speed up ratio of the pipeline as compared to the corresponding non-pipeline system? Possible speed up ratios. Fine. So first of all, let's calculate speed up, which is maximum speed. What is the possible maximum speed up for this particular given scenario? So for this given scenario, S max can be Tn by Tp. Right? What is the Tn? One operation performance time in the non-pipeline system, and we calculate Tn by adding or by summing all the segment delays. So addition of segment delays, 32 plus 34 plus 20 plus 26 plus 38 plus 27. I will need your help here. Can you calculate this? Can you calculate this? And TP, how do you calculate TP? By maximum of segment delays, maximum of segment delays plus this intermediate buffer delay. So TP I can get it from here, maximum of segment delay, which is 38 plus 2 divide is equal to 40 nanoseconds. And this is how much? Can you calculate this is how much? जल्दी से कैलकुलेट कर लो यार, जल्दी से कैलकुलेट कर लो how much it is. How much it is? I need your help in this calculation. Okay, I will also do 32 plus 34 plus 20 plus 26 plus 38 plus 27 is equal to 177. I am getting 177. I am getting. Are you getting the same? 177. 177. Are you getting the same? So the maximum speed up can be 177 divided by 40. Okay, 177 divided by 40, you will be getting 4.425. So any kind of speed up which is lesser or equal to this will be possible speed up for the pipeline. If you have some stalls, if you have some more number of instructions or less number of instructions or less number of operations, based on that, this particular pipeline can give you maximum 4.425 speed up. Lesser than that also possible. Lesser than that also possible means which will be the correct answer? C correct, D correct. C comma D are the possible speed up ratios for this system. Got it? समझ में आया क्या? समझ में आया क्या? Yes or no? So 3 possible, yes. 4 possible, yes. Based on the hazard or maybe other possibilities, number of instructions and all, we can have speed up lesser than 4, but cannot be more than 4.425. That is the maximum speed up. Okay, chaliye another question. Still 10 questions are left. We are left with 10 questions and 20 minutes. Can we solve 10 questions in next 20 minutes? Let's do it. Tired? थक गए? अरे थक गए क्या यार? देखो मेरे को, देखो मैं सुबह से बैठा हूं तुम्हारे सामने इतनी अच्छी सी स्माइल लेके और बहुत अच्छे से आपको एक्सप्लेन कर रहा हूं. इफ यू आर टायर्ड देन टू यू कैन नॉट बी टायर्ड मेंटली. Okay, just because this is the highest level of competition when we are going to fight against lakhs of people, so we cannot get tired here easily. We need to put extra efforts, then only we will be different than other fellas. How we can be different than other fellas? Just because when we will put more extra efforts from our end. Okay, another question number 51. Here it is. क्या बात है, बहुत सारे लोग डैप कर रहे हैं. अरे डैप कर रहे हैं, ये लो मैंने भी कर दिया डैप. Question number 51. Here it is next in front of you. Consider a 6 segments instruction pipeline in which every branch instruction incurs maximum 3 stall cycles. Maximum 3 stall cycles can be incurred because of the branch instruction. Which of the following can be the segment number in which pipeline can evaluate the branch condition? So we know that within, if in ith stage the target is calculated, if in ith stage the target is calculated, then stall cycle because of the branch is I minus 1 and that is given as 3. So I value is equal to 4. So within 4th stage, you can calculate the branch. But look at this. Read the statement clearly and it says that incurs maximum 3 stall cycles. Means, might possible, it can incur 2 cycles also. It can incur 1 cycle also. Which means I can calculate the target maybe in 4th stage, maybe in 3rd stage, maybe in 2 stage. Means you can have option C, B, A, correct. Maximum stalls are free, means in the 4th stage the pipeline is calculating the target. If the stall is 2, then in the 3rd stage. If stall is 1, in the 2nd stage. Answers are A, B, C. क्या बात है. We have so many champions here and all the champions are giving great answers here. Great, amazing, superb, amazing people, amazing. चलिए आगे बढ़ते हैं. Question number 52. As we are going further, we are reaching our closing questions. Fine, questions are not easy at all as of now. Okay, consider a pipeline system which has 5 segments. A segment which takes maximum delay among all the segment is divided into 2 segments of equal delays. Okay, and if suppose the segment had initial delay of 10 nanoseconds, so we had 5 segments initially, and those segments are, let's suppose, S1, S2, S3, S4 and S5. assuming that one segment among those was taking 10 nanosecond initially, and after that you have divided these segments into means what, this particular segment which was taking maximum delay divided into two segments. So you made it like this way: S1, S2, S31, S32, S4 and S5. 6 segment pipeline you made, and now S31 and S32 both are taking 5 nanoseconds. Which of the following cannot be a pipeline cycle time for the new pipeline? For the new pipeline, for previous one, see, this was the maximum highest delay. You look at this, maximum delay in that particular segment was 10. So all these should be lesser than 10. In this one, if you are dividing 10 into two segments, 5 and 5 equal half, look at this, given that equal delays, might possible in the remaining segments, you can have maximum delay 5, possible, or might possible you may have another segment which was having 7 delay. So you have divided this maximum segment delay into 2, 5 and 5, but this 7 is still there. So in that particular case, maximum can be more than 7 also, but of course cannot be lesser than 5. So which can be cycle? Which can be cycle? 5 can be a cycle time, yes. 6 can be a cycle time, yes. 7 can be a cycle time, yes, but 4 cannot be a cycle time. 4 cannot be a cycle time. Only D. Question is cannot be. Question is cannot be a cycle time. कौन सा cycle time नहीं हो सकता? कौन सा cycle time नहीं हो सकता? Which particular cycle time is not possible? So cycle time not possible is 4, just because maximum segment delay even after dividing this 10 into two segments are 5 and 5. So maximum segment delay will be still 5. So less than 5 cycle time is not possible. More than that possible, just because it might possible that other segments may have more than 5 segment delay. Yes, good, amazing, superb, amazing. Another question, here it is in front of you, question number 53. Last 8 questions, question number 53. Which statement is or are true? A general pipeline cannot detect the data dependency. Yes, a general pipeline cannot detect data dependency. For that, a pipeline should have hardware, should have some intelligence, some smartness. Delayed load is the solution provided by compiler. Yes. Operand forwarding can solve all the data dependencies. No. Just because if there is a data dependency because of load and store, then operand forwarding cannot help. Operand forwarding can help only from ALU to ALU data dependency. Data dependencies always create stall cycle. That is also not true. False. Might possible you may solve it using the operand forwarding, or might possible the data dependencies are of false dependency type. If WAW or WAR type you have, then in that particular case you may not have any stall cycles. So option A and B are correct. Okay. A and B only, not D. Dependencies always create stall cycle. Not true. Question number 54. Which of the following is or not false? Not false means true. Each segment is used only once in every pipeline for one input. False. In the non-linear pipeline, you may use one segment used for more than one time for one input. So, false. As the number of tasks increases, the speed up of pipeline also increases. Yes, that is true statement. For one input, pipeline takes more time than non-pipeline system because of synchronization and register delay. Yes, that is true statement. If we consider that all pipeline segments are filled with inputs, then the speed up of pipeline becomes independent of number of tasks. Is that true? If pipeline segments are full, means ideal case, then the speed up becomes independent of number of inputs. No or yes? Yes. Speed up, then you calculate by directly Tn by Tp. That is the maximum speed up in the ideal cases. In that case, yes, speed up becomes independent. So what are the not false true statements? B, C, and D. These are the true statements. Clear, cool. Should we go for the next question? Last six question for you guys. Next question number 55. Which of the following is or are true? True statement. Any IO operation can be performed always after current instruction execution in CPU. Any IO operation can be performed always after the current instruction execution in CPU. Is that true or not? Is that true or not? Is that true or not? बताओ जल्दी से बताओ. Any IO operation can be performed always after current instruction execution and CPU false. Why? Just because current instruction is going on, might possible CPU will stop itself and will give the control of the buses to DMA, and DMA can perform some IO data transfer with memory. Possible? Yes. Possible. So false. DMA controller can start data transfer immediately after getting DMA request from IO? No. No. Why? Just because DMA does not have the bus controls. So DMA first take the bus control, after that will transfer the data. So after request from IO, DMA cannot perform the data transfer. CPU generates memory read signals or write signal for DMA transfer? No. CPU does not generate these memory read write signals for DMA transfer. DMA controller itself generates these signals. DMA controller itself generates these signals. Next, CPU generates interrupt acknowledgement immediately after receiving the interrupt? Always? No. Why? CPU may not generate the acknowledgement or may take a little bit time to complete the current instruction, and after that will generate the acknowledgement. Okay, so CPU will not immediately generate the acknowledgement. That's why all four are false. No any true statement. Got it? Okay, fine. If you guys are enjoying this lecture, one request I want to have from your end: as soon as this particular lecture will be over, please come back on the same lecture and drop a comment after the lecture is over, so that the people who will watch this lecture later on can understand that what will be this particular session have, what this particular session will have for them. So please do that particular thing. Once entire session is done, drop a comment after the session is done as a video. When it will be uploaded as a video, drop a comment on that particular video. It will definitely help lots of students to decide that this particular video will be worth watching or not. You are listening, you are enjoying, you are solving the questions. If that will be benefited for them, definitely they will watch later on in the offline mode. If you will drop a comment, and reading your comments will help them. Okay, fine. Next question number 56. If a word preparation time in IO device and word transfer time to memory from IO device are same, means if you remember my lectures, preparation time is some x, or let's say some t time, and ty is also t time, same to same, both are same to same, preparation time and transfer time same to same, then CPU is blocked for 100% in cycle stealing mode. Yes, in cycle stealing mode we calculate percentage of CPU blocked by what formula? Ty divided by Tx into 100%. So it is true statement. 50% in the cycle stealing mode? No. 100% in burst mode? Yes. In the burst mode we calculate In the burst mode, we calculate the percentage of CPU blocked by T divided by T plus T into 100%, which is 50%. 100% in burst mode? No. 50% in burst mode. A and D are the correct answer. Got it? Got it or not? If you got it, then let's solve next question. Only 4 questions are remaining for us. Question number 57. Which of the following is or are true regarding IO mapped IO? IO mapped IO. Less IO devices possible as compared to memory mapped IO? Yes, that is true. IO devices have their own address space in IO mapped IO? Yes. Memory access address modes can be used for IO also? No. No, no, no. It is true for memory mapped IO, not for IO mapped IO. No, no, no. And then CPU differentiate between memory and IO using control signals. CPU differentiate between memory and IO using control signals? Yes. For IO mapped IO, we have memory signals separate and IO signals separate for control signals. So that is true. A, B and D correct answer. Next question. Last 3 questions only. Last 3 questions only. Not false. Not false means true. DMA controller is a special purpose processor? Yes, that is true. CPU can perform some operation during DMA transfer? Yes. Internal operation which does not require buses. Possible. CPU can enable DMA hold acknowledgement after instruction fetch cycle? Yes. CPU can enable hold acknowledgement means granting the buses to DMA possible. DMA transfer stops when starting address becomes 0. Yes, no. When the data count becomes 0, only DMA transfer stops, not the starting address. Okay, so it's a false statement. A, B and C are correct. Okay, okay, okay. Next question number 59. Last 2 questions only. Which of the following is or are true? DMA transfer is always faster than IO. Interrupt IO? Cannot say. DMA transfer is always faster than interrupt IO for the memory to IO transfer. That's it. Not always faster than interrupt IO. False. Interrupt IO is always faster than programmed IO. Yes, that is true. A system can use either DMA mode or interrupt mode for data transfer between memory and IO. This is also true. You know, sometimes when memory and IO are having just 1 byte or 2 byte data transfer, then it is possible that we will not go for DMA transfer. We can go for interrupt IO just because it is better. Why better? Just because for DMA transfer we need more granting the things. So CPU can only go for data transfer between memory and IO by interrupt mode if the data size is small. Possible. DMA can transfer the data from IO to CPU. DMA is used for data transfer between memory and IO. Okay, IO to CPU? No. So what are the true statements? B and C. And here it is, the next very last question for you. Here it is. A DMA controller has data count register of size 6 bits. Fine. A file is to be transferred using the DMA controller from IO to memory of size 12 kilobyte. Fine. If 12 kilobyte size I'll have to transfer. And we have 6-bit data count register means 2 power 6 minus 1 which is 31 bytes. Which is 31 bytes we can transfer in a single time. To transfer 12 kilobyte using 31 bits in single time, how much time maximum is needed to DMA controller? Maximum time DMA controller will take control from CPU is 196. No, that can be minimum. Let's calculate. 12 kilobyte divided by 31 byte. Can you calculate that? 12 into 1024 divided by 31. How much it is? How much it is? 12 into 1024 divided by 12 into 1024 divided by 31, and it gives you 396. Oh, I am getting wrong here. Yes, it's not 31 byte. It should be 63 bytes. Okay, my bad, my bad, my bad, my bad, my bad, my bad. So it should be 63 bytes here. So if 12 into 1024 divided by 63, I get 195.04, which is 196 times. Minimum times the DMA take. The control from the CPU is 196 times. That is the minimum time. So maximum time, no. Might possible DMA is not transferring 63 bytes in single time. It can be more. It can be more than that. It can be more than that. It can be more than 196 times, but minimum times the DMA controller will take the control of the buses is 196 times. Minimum times. Minimum times, not maximum. Minimum times 196 times. Minimum is no this one. Minimum is not this one. Only B option is correct. Maximum can be anything. Maximum can be 12k times. 12k times. How? In one time, one byte is transferred. In one time, one byte is transferred. So maximum time DMA controller is taking the control can be more than 196, but minimum 196 times the control should be taken. Minimum 196 times the control should be taken. Option B is correct. Okay, so this is the end of the session. If you guys are learning from us and enjoying, please drop a comment after the lecture so that remaining members can access these lectures with more and more clarity that what kind of lecture we are providing here. These three courses are going to change very soon. As of now, these courses are going on, and 3 p.m. Monday to Friday mathematics is going on. Please go and check it out. Please go and check it out. That lecture also, engineering math also you can learn. If you want to learn data structure, already I am taking a class 10 a.m. daily. Apart from that, today I am having another session at 12 p.m. Yes, within half an hour only, 12 p.m. another session I am going to have about PYQ of data structure, and in that PYQ I am going to solve the questions of stacks. Questions of stacks I am going to solve. Okay, questions of stacks I am going to solve. So you can come live on YouTube on the same channel 12 p.m. We will solve the questions of stacks in the session. Okay, fine. This is the team helping you a lot. So please acknowledge using your likes, using your comments, using your shares with multiple friends, so that these fellas, all these fellas including me, will be motivated to bring you lot content. Fine. If you want PDF of the classes, you can go to this particular page and you can check it out. All the PDF of our classes are going to be dropped here in this channel of Telegram. If you want to be connected with us, you can go to the Facebook and you can be connected with us on these Facebook pages. And these are the things which you need to spread the words about. The channels which we are having as our family for every engineering branch. For electrical, we have Creatrix page. Just let them know of the electrical branch if they are not aware about the channel. Then mechanical, this channel, Gate C, this channel, Telugu, this channel, कंप्यूटर साइंस के लिए ये चैनल है. अगर आपने सब्सक्राइब नहीं किया है तो चैनल को सब्सक्राइब कर दो एंड नोटिफिकेशन ऑन करके रखो, so that you will be getting the notification whenever the live classes will be there. Share the sessions as much as possible every time. And if you like the session, one more thing you can do is please do one thing. Please do one thing. If you like sessions a lot, then go to your social media, share the link of your social media. You can share the story, you can share your status maybe on WhatsApp or Facebook or any kind of social media with their link, these links and our names, so that maximum number of students will know about our classes. You can do that if you are really liking such sessions, and keep liking such sessions so that we will be motivated tried a lot to bring lots of content for you. So till then, I am now closing this particular session. Happy learning. Thank you so much. We will meet again. Till then, have a nice day. Bye bye.